So welcome back. Hi everybody. In my last class, we discussed about the conservation of linear momentum. So I told you on that very day that when some F, that is force external, is equal to 0, then P, what is P? That is linear momentum, that is constant. On that day I told you one example also that a gun recoil, like there was a gun that was the initial stage of this gun, and final stage of this gun when this bullet is fired with velocity v and mass m, and this was mass m, it will recoil with velocity v, capital V. It's a small v, it's a capital V. So initially this was m plus m, because this bullet was inside uh, this gun. So what was the initial momentum? That was p. I told you that p is equal to constant. So like what was the initial momentum? What is p? P is equal to m plus m into what is velocity, and velocity initially it is at rest, and you can see there is no external force. So what happened at the end? It gun start moving backward with velocity with this capital V, and this bullet will move with with velocity small v. So what is the momentum I told you? Like m v minus, and what about this, as the direction is in opposite direction, so that's why I put it minus sign here. So m v, but the thing is that momentum means momentum is constant, means initial momentum this one is equal to this one. So m plus m into 0 is equal to m v minus m capital V. So what came out? M v minus m v. So it was like this, capital M by m into v. This was the relation between their velocities. Okay. The thing is that this velocity is with respect to Earth, and this velocity is also with respect to Earth. What with respect to Earth means? That is as seen from Earth, or we can say as recognized from Earth, or Earth frame of reference, or you can say Earth frame of reference. No need to use this word frame of reference. You can see as seen from Earth, means with respect to Earth. So this was the thing that I told you in my last class. So I think now, like you have some idea about what is conservation of momentum. So let's see the rocket part. How rocket works, means how this momentum part is applied to the rocket section. So let us suppose this is your rocket. and its initial mass is m naught. The thing is that the gas, you can say, or you can say fuel comes out in the form of gas that comes out at a rate at some rate, means dm over dt. I am saying it's the rate by which this fuel comes out in the form of, you can say, like uh, if I told you on that very day that suppose uh, like thousand liter, consider, let us consider like 1,000 liter of a fuel is there in the rocket. So like, and that 1,000 liter means when rocket goes to some height, that fuel reduces to you can say 800 liter. So that 200 liter is lost, you can say. So there will be a mass change, you can say, because initially the whole mass of the rocket will be the rocket weight plus 1000 liter fuel weight. But when it reaches some height, 200 liter of the fuel is lost, that came out, you can say. And so at some height, what would be the weight? It will be what would be the mass, you can say. It will be that the weight of the rocket and plus that of 800 liter fuel will be there. So like some, so this is what rate by which means uh, this is the rate by which the fuel comes out, you can say, in the form of gas or anything, it will come out. So the thing is like, suppose after time t, you can say, after some time, you can say, like here, after some time when it reaches to some height, you can say, or the mass become m. And suppose this came out here with some velocity u. Okay, the thing is that this is relative to ground, or you can say with respect to ground. This velocity is with respect to ground. Okay, so like suppose this is the initial part and this is at some time t, at some time t. This much of you can say came out. So like what would be this m? So this m means is equal to m naught minus at some time t. I told you here rate dm over dt. So this will be dm over dt into this time. So this is the left mass of this rocket. So this much I think you got it. This is the mass left, you can say, after time t. Like I am moving from this initial position to this position after time t. Let me highlight it. This is your initial position, this is your position after time t. Now let's create another position. 1 minute. Now this is after time t plus delta t at some time t plus delta t. Means this is at time t. Remember this thing. This is the initial position. Initial position, its mass was m naught. After time t, the mass reduces to m because this is the rate by which this fuel is coming out, you can say. And this is the mass left. Okay. Now, after some time t, let's see. This is your rocket. Now it reaches more above the earth, you can say. So like here, suppose there is a reduction in mass, you can say m minus mass reduction is suppose m minus delta m. In delta time t, there is delta m reduction in mass. And what is delta m? This suppose this delta m came out. This is delta m that came out and it goes here downward with velocity u. That is also with respect to ground. Okay, and this rocket, suppose at t plus delta t time, the rocket velocity is in upward direction. What it is? Suppose it is velocity v. So what would be the momentum at this point of time? I will be considering this point of time and this point of time. Means at time t and at time t plus delta t. So like what would be the momentum at this point of time? P is equal to m into v. So what it will be? This m into suppose this rocket is going upward with this velocity v. Like here it's going upward with velocity v. The thing is when there is some this mass delta m came out, there will be increase in velocity, you can say v plus delta v. Okay, delta v is a small v, there will be a change in velocity, you can say increase in velocity, there is a decrease in mass, and this delta m came out in backward direction. Okay, so the thing is I am considering this position at time t and at time t plus delta t. So what is the momentum here? So like I told you that don't consider this section here because I am considering this case that when so I am considering it like at this position its mass was at some time t, its mass was m and it's moving upward with this much of velocity, and at delta time t this much of delta m came out here with velocity u, and this record there is an increase in rocket speed with v plus delta v. So I am considering these two part. Okay, this one and this one. So what is the momentum here? So like this into this m into v. this m into this v. What it will be? That will become complicated. So like remember this thing, this m and this velocity v. And what would be the momentum at this point of time? So it will be, you can see here, like m minus delta m is the mass. So m minus delta m is the mass, and v plus delta v is the velocity. V plus delta v is the velocity. Now this will be in, you can see here, like this u is in downward direction, opposite direction. So I will be putting minus sign here. Okay, so like here it will be for this delta m, and this velocity u, for this delta m and this velocity u, it will be delta m. And I'm putting minus sign here because the direction is in opposite direction. I considered the upper part as positive and negative direction. So means when the velocity is in this direction, I consider it as positive, and when it is in opposite direction, I considered it as negative. Okay, so this will be delta m into u. Open it up. M v and plus m delta v minus delta m into v minus delta m delta v, and this one minus delta m into u. The thing is that delta m and delta v will be very small. Delta m is small and delta v is also small, so it will become very small. So we are going to avoid it. We are going to neglect it. Okay, so it will become mv plus m plus delta v minus delta m v minus delta m u. We avoided it or we neglected it because it's a very small value, because delta m is small and delta v is also small. So its multiplication will be very small value. Very means we can neglect it, so you can say, because both are delta part, so we are neglecting it. Now the thing is, by conservation of momentum, the thing is like momentum at time t. This is the momentum at time t, and this is momentum at time t plus delta t. So by conservation of momentum, like I told you in previous one, we will be equalizing these momentums. So it will become like this momentum mv is equal to this momentum, means mv plus m delta v minus delta mv minus delta m u. You can see here this mv and mv will get cancelled, and we will be having m delta v is equal to this delta m v plus u. So what would be the scenario? Let me put it somewhere and adjust this thing here. I'm placing it here, like I'm writing it here. I'm continuing it here. From here to here, I'm continuing. So like what it will become, delta m delta v is equal to delta m v plus u divided by both sides by delta t. So it will become m delta v over delta t is equal to delta m over delta t v plus u. So the thing is, you can see it like I told you initially, when we are considering any delta v over delta t, so like when this delta t tends to 0, it is not 0 means tends to 0. Tends to 0 means that will not be 0, but it is very much small value that it's nearly to 0. So we can write this thing delta v over dt as dv over dt. Like I told you earlier also, like how to see these things. Like when you are writing delta v over delta t, any delta part you can say, like if it's a delta m over delta t, for that also I will be saying the same thing. Like when delta v over delta t is there, and you will come across limit part, you can say limit chapter in your calculus section in maths. Okay, so in that it will be there, that's the limit part. Means when this delta t it's that much of small, you can say that it's not 0, but it's near to 0. It's that much of a small value, you can say. So we call it as a differential element, you can say. The thing is that you will come across this thing in your limit section. That's separate chapter in your maths calculus section. That is limit. Means calculus includes three parts, like maximum is there, like limit part is there, and integral calculus is there, differential calculus is there, and that is widely used in physics section. So you should be aware of these things, but no need to get panic. Like you can understand this thing, like when this delta v over delta t is there and this delta t is that much small that it's near to 0, so we can write it as dv over dt. So same thing I will be saying here, this delta t is that much of small, this delta t is that much small that it's means like here what I did here, like this is at some time t and this is at some time delta t. So what I am considering it a very small time difference. So this delta t, you can say, so this equation becomes m dv over dt is equal to v plus u dm over dt. So the thing is, you can see here, like here we got this equation like m dv over dt is equal to v plus u. What is v? V is the velocity at time t of this body, and like at t plus delta t, what happens? This much of delta mass is ejected. This much of mass delta m is ejected. You can say this much of delta m mass is ejected. So you can see here, this is in this scenario, like m dv over dt is equal to v plus u dm over dt. And what is dm over dt? I think I discussed it here. I showed you here. This is the rate by which the mass is ejected. This is the rate by which the mass is ejected. Like what is this m? This m is this much of mass. Okay. So remember this equation, because I will be telling you, or I think I do one thing. I will rub rest of the things and I will keep this equation, and I will be removing rest of the things. Okay. So remove it. So the thing is, I told you, yeah. So like there is one concept of, you can say, like what equation came out from here. First see this thing. Okay. What came out from here? This is m dv over dt is equal to v plus u dm over dt. And actually, the thing is, you can see here what this part, like when you are going to see this section, what came out of your mind is this is mass, and what is dv over dt? What is dv over dt? That is what? This is acceleration. So what this mass into acceleration is? That is force. That is force. What is force? Force is equal to mass into acceleration. And what is acceleration? We can write it dv over dt. I told you dv over dt. So this is some force, you can say. So what this force is? So like there is one more concept that is called as the thrust force. So what it says that this is the force generated when certain mass leaves. Let's consider the leaves part. Okay, leaves the system. The thing is there, like this thrust force, you can say the full definition of this thrust force, you can say like this is the force generated when certain mass leaves or enter into the system. I am not considering, means what my scenario is, that this delta m is leaving the system. Which system? Like you can see here, like this is the at time t, the mass was this much, and at delta tt plus delta t time, there is a reduction in mass. You can see here, like there is a reduction in mass, and this delta m, like here I remove delta m, and here this delta m is coming out with this velocity v. So what thrust force says, that when this is the force generated when some mass leaves the system. I am considering only when, like what the exact definition of force is, thrust force is, like when certain mass leaves or enter into the system. But my scenario is that here this is leaving the system. You are getting or not? The thing is here delta m mass is leaving the system. You can see here this is the delta m mass which is leaving the system. This is leaving the system. So there will be a thrust force. Means this thrust force will be, you can see here, like in this direction. Means this, there will be thrust force that will act on this rocket section, and there will be, means, so like there will be a thrust force, you can say here, like FTHRUST, that will act on this system. That's why its velocity will become v plus delta v, you can say. And what is this thrust force? This is what your F thrust. V plus u dm over dt. Like here we got this equation. I told you what this equation is, m dv over dt. What is this? A is acceleration, And what acceleration is dv over dt. That's why this is this is force, this is force. And what this force is? This is the thrust force. This is the thrust force. Like here you can see here, this mass delta m leaves the system, and due to this leaving of the system, this rocket will experience a force. That is what is called the thrust force. Okay, because here, like there will be delta m mass came out of this rocket in some direction with this velocity, you can say u velocity. So so like now I think you might be having a good idea, like if some rocket is going upward, you can say, and if some rocket is going upward, and suppose this is the rate. I told you initially that rate at which the fuel comes out in the form of something, or is something, you can say, this rate by which the fuel comes out, or like there will be reduction in mass, you can say. So that comes out in this direction, like the rocket is moving with velocity v, you can say, at some point of time, and the fuel comes out with velocity u. If this thing is given like this, if these things you have, so what is the thrust force at that point of time that rocket will experience? So like this is the thrust force that it will experience. So this is the thrust force, this is the thrust force that will act on it. Due to this, there will be a change in velocity. Why there is a change in velocity? Like some acceleration. If there is a velocity change, it means it is having some acceleration. So this will be a change in velocity. So I think now you might be having the idea what is thrust force. Like if your rocket is going upward and some mass came out with some velocity, you can say. So like when some mass leaves the rocket, so like some thrust force will act on it. So this is what the thrust force is. Like it is the force, it is force generated. Why it is generated? When some mass leaves the, certain mass leaves the system. This is the rocket, you can say. So this is the thrust force generated. Okay. So that's the main thing. Now, the thing is, this is the ideal condition, you can say, and I'm not considering the gravity. So let's think about the gravity. But I will not, I will do one thing. I won't be rubbing the equation, because I think that will, I will not rub this equation because I have to explain it a bit more. So like so what I told you that this is your rocket moving with some velocity v at some point of time t, and at some time t plus delta t, some delta m mass came out in this direction. with velocity u. So, and its velocity now become v plus delta v. Okay, so the thing is here, like this delta m leaves this system, so there will be some force acts on it, you can say, in upward direction. Okay, so like this is m and this is m minus delta m. So F thrust will act upward direction. Okay, the thing is here, like now I think you have the idea, like when this rocket will go up, so it will experience some thrust force. Okay, so like consider some time, like at some time you can say it is having m1 mass. So this m1 will be acting downward. This m1 into g force will act downward, and due to as like it keeps on releasing, the rocket keeps on releasing something, like, so let's consider it suppose at time t1 and any point of time, so it might be experiencing a thrust force in upward direction, you can say F thrust. So what would be the total force, means that would be acting upward, that would be acting, because in my last scenario that condition we considered, that is the ideal condition, like there we didn't consider this gravity, because the thing is that the m1g will act in downward direction. So what would be the net force that will act in upward direction? You can say F net force. What would be? It would be in upward direction. I am talking about in upward direction. So you can see here, like F thrust will act upward, M1G will act downward. So what will be the force in upward direction? So F thrust minus M1G, and F thrust we calculated here. dm over dt, this is the rate by which the fuel is ejected, or some means mass keeps on reducing. There can be any scenario, because the rocket, it can be any scenario. For your understanding, I considered a rocket part, but it can be any scenario. It can be like a truck filled with sand. Suppose a truck is there, means any scenario can be there, like suppose a truck is there and it is filled with sand, and there is some hole in it, you can say some hole in it. So like any question can be, this type of question can be here. So like suppose m mass is here and some hole is there, so that sand came out of this sand is coming out of this truck. This truck is moving in this direction, and I suppose at this point of time, here, when it reaches here, and there is, you can say, delta m minus delta m part of the sand came on the road, means because the thing is that this, there is some, you can say, hole is there, and due to which sand is coming out continuously from this uh, hole. So suppose dm or dt is the rate by which the sand is coming out from this hole. So, and there is, so any scenario can be, any type of scenario can be there, but the concept that will be implemented will be the same. So don't like the scenario can be like this also, like the sand is coming out, or truck is moving, sand is coming out. Any scenario can be there. So you can see like here also the same thing is here, like the sand is coming out the hole, and there will be reduction in mass, and so this thing is also there. Okay. Now there is some word which is called the exhaust velocity of an emerging gas. This word is there. Exhaust velocity. Exhaust velocity of emerging gas. The thing what I am saying, that is of rocket. The thing is, I told you this. Suppose this is emerging gas, and this is the velocity with which, like I told you, velocity with which it is coming out. But the thing is here, this velocity is with respect to earth. With respect to earth means, with respect to earth means as seen from earth, or you can say in the frame of reference of earth. So this u is with respect to earth. So this is not the exhaust velocity. The exhaust velocity is the velocity of this delta m, which is with respect to rocket, which is with respect to rocket means as seen from the rocket. But the thing is, rocket is going upward with velocity v, and it is coming downward with velocity u. So this v plus u, the thing is why we consider this, like means, like when some, suppose some person is sitting on this rocket, some person is sitting on this rocket, so he will see that this delta m, like I am standing on earth, and I am seeing both rocket and both delta m from my eyes. So what I will see, like I will see that this rocket is going up with velocity u v, and this delta m is coming down with velocity u. But the thing is there, suppose some person is sitting on this rocket, so he like for him, like when he will see this delta m, he will say that this delta m is coming down with how much velocity, that is v plus u. I think I discussed one chapter, that is one part, that is relative velocity. So there I told you these things, like how to calculate this velocity. So the thing is, remember this thing, like when someone will see on this, like I am standing on earth, and I will see this rocket and this delta m. So for me, this u is with respect to earth. But the thing is, when this person is standing or sitting on this rocket, he will see that this delta m will move with velocity v plus u. So what is this? This is the exhaust velocity of this emerging gas. Okay, so this is what is called the exhaust velocity, because this velocity is with respect to the person who is sitting inside the rocket. Okay, so the thing is that this V plus U is used here in F thrust. Like you can see here, this V plus U is here. So what is your F thrust? You can write F thrust is equal to what? Exhaust velocity. Exhaust velocity of emerging gas into dm over dt. This is V plus U. So this is exhaust velocity into dm over dt. So I think whatever that is needed for conservation of linear momentum, that I already discussed, most of the things I discussed here, and have a look into it, and I think yeah, that's all from my end for today. So I think that's all for today. Thank you.